Welcome to the video. In this video, we are going to see how to build a linear regression model using Statsmodel library. In the previous video, we saw about how to build a linear regression model using sklearn. So in this video, let's see how to build the regression model using Statsmodel. So first, I will import all the necessary libraries like I will import pandas, numpy, seaborn, and matplotlib. After that, I will read a dataset. So this is my dataset. In this dataset I have this is a dataset about the user phone. So it has the information like brand name, OS, screen size, the network, the 5G or 4G, the main camera, selfie camera, internal memory, RAM, battery, weight, released year, days of use, the new market price of that mobile, and the user price. By using this, we are predicting the user price by using all this information. So this is a target variable and all the other columns are the independent variable. So after reading file, then do some sanity check. So first I will check the shape of the data. So the shape of the data is 3571, means the it have the 3571 rows and 15 columns. After that, if I now check for my information of the dataset, it will give the information like the entries. It have the 3571 entries, and in total it have 15 columns. So you will find that all the information about all the columns like the non-null counts and data type. So here we can see the brand name and OS. It have the object data type. It's a categorical column. Then in the screen size we have the float, and the 4G and 5G we have the object data type, like that. After that, if I now check for the null counts, so df.isNull.sum, it will give the null counts of each column. So here we can see that the brand name till the 5G column, it don't have any null value. In the main camera MP, it have the 180 null value, and the selfie camera is the 2 null value, like that. In the internal memory it have 10, and the RAM it have 10, and the battery it have the 6, the weight it have 7. So this many null values it has. So let's impute that in the imputation session. Before that, let's find out that whether there is any duplicates value. So df.duplicated.sum, it will give 0. That means it don't have any duplicated value. So after that, let's do some EDA to understand the distribution or the dataset. So first I will describe the data to get statistical summary. So this is the description of the data. It has the description for each column in terms of mean, standard deviation, and the range from minimum to max, and the 50th percentile, like that. By this way we can find the distribution whether it's right skewed or left skewed. So here we can find that the main camera, it have the 3391 counts. Then the mean is 9 point something, 9.4. Then after standard deviation it's a 4. Then it's a not right skewed or left skewed. It have the normal distribution, I think. Then after that, let's describe the object column. If I describe the object column, it will give the information like the unique count. So in the brand name we have 34 unique counts, and the OS we have 4 unique counts. In the 4G and 5G we have 2 unique counts. After that I will visualize some data to understand the distribution. So I will do KDE plot to understand the skewness of the data. So by using this I can get the skewness of the data. So here we can see that in the screen size we have the right skew. Then in the main camera also we have some modes, and here we can see all the distribution of the data. So let's see in the target variable where it's the right skewed, or yeah, target variable is right skewed. So we need to transform the data before fitting the model. So let's see how to do that also. Then after that, in order to understand the outlier, I will do the box plot. So by this way I can do the box plot for each numerical column. So this code will create a box plot for each numerical column. So here we can see that in the weight and in the new price I have many outliers. Don't do the outlier treatment before. First check for the model, how it the result of the model, then we can decide whether to do the outlier treatment or not. So to understand the relationship, I have the scatter plot. So I draw the scatter plot between the each variable and fixed variable, that is user price, that is my target variable. So I have the scatter plot like this. So here we can see the concentration of data is whether there is a relationship. So here in the new price and the user price, here we are seeing the positive relationship, means that when the new price increasing, the user price also increases. So after that, let's see the correlation. So this code, particularly this code, will give the correlation matrix by using heat map. I got the visualization of the correlation. Here we can see the correlation of each. So the days used and the selfie camera MP have the negative correlation. Then this one, then the battery and the selfie camera MP have the 34% of correlation, positive correlation. Then in user price, the days used have the negative correlation of 47%. Then the new price have the major impact because it has 93% correlation with user price. After that, let's do some treatment. After the it is done, then after we will do some missing value treatment. So here we can see the missing values. In the main camera, I have 180 missing value. So let's impute them. So for discrete numerical data, discrete means it's a full value, the like main camera MP, selfie camera MP, and the internal memory and the RAM. It have the particular expected value. So we will fill it with the mode of that column. For the continuous numerical column like battery and the weight, we will impute with the median. So after filling the missing value, let's now check for the null values. Here we can see the null values imputed. So there is no null value in our dataset now. So after that, let's do some encoding because we have some categorical data like brand name, OS, and screen size. So let's do some encoding. So in the brand name, we have many categories, like we have many unique values. So doing the encoding of this will be the huge process. So we can do feature engineering to reduce this the category. Otherwise, we can drop this. So for now, I will drop this column. So I will drop the df dot brand name. Okay. After that, let's do some encoding of the other column like 4G and 5G. I will just replace the 4G and the 5G with the S and no with 1 and 0. That's a boolean value. 1 means true, 0 means false. So for S, I will impute with the, I will replace with the 1, and for no, I will replace with the 0. Same for the 5G column. After that, creating extra column, I will drop that 4G and 5G because I have this column in place of the 4G and 5G. So I no need to hold this 4G and 5G, so I will drop that. So after doing the replacement, if I now check for my data, so this is my data. I have the 4G and 5G column, 4G and 5G column like with the boolean value. Now I have only one categorical value. So if I want to get a dummies, means I want to get a encoding of that, so I will use pd means pandas to get dummies. So this is the code will get use the dummy variable. So pd dot get dummies data is my this data frame. So I will give the column. So column is that OS. By this I can get the dummies for that column. So if I now check for the dummy after doing the encoding, I will store that new data with the dummy. So from now the dummy is the data frame I have to use. So if I now check for dummies, so here we can see all the columns is now in the numerical form. So from here I can fit the model. So if I check for the data types, so dummy.dtypes, I can see all the variables in the form of numeric, whether it's a float or integer. No one is in the form of object. So the pre-processing is done. Then after that, data is ready to fit to the model. Then after that, I will visualize that target variable, whether there is any skewness in the data. So here we can see that in the user price, this is before transformation, this is after transformation of the user price. So here we can see that the right skewness of in the user price. So I will do some transformation using the KD log transformation. So log transformation to reduce the skewness in the target variable. So here we did the log transformation by using np.log, the dummy. The dummy means my data frame, dummy, that column, the user price. So this code will do the transformation, that log transformation of the data to reduce the skewness in the target variable. So after that, I will use the dummy to fit the model. So in order to build the model using Statsmodels, I need to import this library like import statsmodel.api as sm. And to split the train and test the data, I have to import from sklearn.model selection import train and test. After that, define x and y. So x is my data without user price. So if I get the data frame without user price, because that is my target variable, if I get the data without this, that's my x. Then the y is that dummy dot user price. So we define the x and y. Then after that, in the stats model, we need to add the x to the constant. So this code will add the x variable to the constant. So I will name it as x underscore c means x constant, the sm dot add constant, the x variable. So this will add the x to the constant. So after that, let's split the data into train and test. So that we all already imported that train and test. So this code, the train test split, give the 4 output, that is x train x text, y train y text. So here we define the text size mean 30%. Out of the whole data, 30% is split to the text. Then the random state is equal to 42 to make sure that every time I run this code, it selects the same data. So after train and test split, we will fit the model. So we will use sm dot, that stats model library dot capital OLS means ordinary least squared bracket y train. We will first give the y train, after that x train, then as type float, that this is necessary because it will give some error. After that, after closing the bracket, we will fit the model. So the model is fitted now. Get the summary of the model. That's easy. Our regression model is stored in the model. So model dot summary, we will get the summary. It will give the summary of everything means r square. First we will check for the r square whether it's more than 62%. Here we can see that the r square is more than 86 percentage. So one condition is met. After that, we will check for the p-value of the each variable. So here we can see all the column information. So we will check for the p-value. It should be below 5%. For dummy, so here we can see that for the screen size, all the p-value is below 5%. But for the 5G, it have the 18%. But for the other category of the same column like 4G, here we can see for the 4G and 5G, it is a dummy. So we don't consider the p-value for the dummy. We'll consider p-value only when all the variable, all the category of that particular column is more than 5%, then we remove that. Otherwise, we don't remove that for in case of dummy. So here the p-value is all the variable is sorted. Then we will check for the prediction. So let's check whether the r square, yeah, r square is more than 62. Then all the variable p-value is within 5%. Then we will get the predicted y. So the predicted y model dot predict, we will give the x test. We already split the data into x text and train. So we will give the x test data as type float. So it will get the predicted y. After that, if I check for my predicted y, so this is my predicted y. By using predicted y, I can get the residual. Residual means the difference between the x y test and y predicted. That will give the predicted, the residual. After that, let's calculate the RMSE. So RMSE is calculated by the residual. First, RMSE means what? It's a residual. Means residual square. First, I will get the square of the residual. So residual into 2, it will give the square. After that, I have to get the mean. So I will get the mean. So this code will get the MSE, means mean squared error. After that, I will take the square root. So the whole code give the root of mean squared error. So this is how I can get the RMSE. After that, I have to get the maximum possible error. So maximum possible error means the mean of the y test, means the average of the y test. So this is the average of the y test. I need to check the how much percentage is the residual of the y, the maximum possible error. So if I divide this by this, I will get the percentage like here. So this should be within 10%. So RMSE should be within the 10% of the maximum possible error. So here I can check like this. I divide the RMSE by maximum possible error. It will give the percentage of the RMSE of this. So here we can see that is 6%. So this is within 10%. So no problem. The condition is met. So the RMSE is within 10%, the maximum possible error. So the condition second is met. Then after that, as a third condition, we will check for the residual. So let's validate the residual condition. So first condition is the mean of the residual should be 0. Here we can see the residual of mean is 0. Then the skewness, that should be normally distributed. So if I check the skewness and the KD plot, it will give the distribution. So here we can see slightly left skewed. So the condition is not met. We need to do some more works on this to get the normal distribution of the residual. Then the scatter plot. Then the third condition is there should be a constant relationship between the predicted and the residual. So here the scatter plot don't give the line, so I have converted that residual and the predicted value into data frame. After data frame, I will get the LM plot that will give the line like this. So here in the line we can see there is a constant relationship between the predicted and the residual. So the condition is met, but the normal distribution of the residual condition not met because of the left skewness. So we need to do some more works on that. So this is the procedure of building the linear regression model by using Statsmodel library. So in the Statsmodel we can get the p-value. So we can remove the columns with a more than 5% p-value. So in this video we learned about how to build the stats model using how to build the linear regression using the stats model. So first we import all the library, then do some sanity check of the data. After that we did the exploratory data analysis to understand the distribution, outliers. After that the relationship of the data, we got the correlation matrix, the heat map to understand the relationship. Then we did the missing value treatment by imputing the data. Then we did encoding of the data. Then after that we fit the model. Here we fit the model. We did the transformation of the data to reduce the skewness in the target variable. Then we fit the model by using Statsmodel library. First we define x and y variable like this. After that we add a x to the constant, x underscore constant sm dot add constant. After that we split the data into train and test. We fit the model by using sm dot capital OLS. After that we get the summary of the data. We check for the R square whether it's more than 62%. Then we check for the p-value of the all the column, whether here we checked about the p-value is less than 5%. Yeah, we got the p-value less than 5%. Then after that we checked for the predicted y. After getting predicted y, we got a residual. We calculate the RMSE of the model by using this. Then we check the condition of the RMSE, means that should be within 10% of the maximum possible error. That condition also met. After that, we check the condition of the residual, like the residual mean should be 0. That condition is met, then there should be normal distributed. The residual should be normally distributed. That condition is not met because there is a left skewness in the data. Then there should be a constant relationship between the residual and the predicted y. That condition is met because here we don't see any pattern like the increasing or decreasing. Here it's a constant. So this is how we can build a linear regression model using Statsmodel library. So thank you for watching. Stay tuned for the next.